but we have to begin from somewhere. And Qiskit is a platform, an open source software for working with the new way and make computation. And mainly to understand the new levels of and artifacts made by circuits, pulses, and algorithms. Of course, many of you don't remember the beginning of the era of massively computation since the 80s of the past century, when we have to understand the real things where things happen. And 40 years later, we return to some kind of rewind to the circuits and the algorithms. Understand this primer about quantum, Python, and Qiskit also as a starter on fire, some form of ignition, to understand the real meaning of the words circuits, pulses, and algorithms. The names are equal, but the approach is really very, very different. This is a picture about a quantum computer. This picture remembers the old computers of the 40s of the past century. And what we can expect is that all this machinery will be even more diminutive, even more simple. Simple sometimes is the aggregate of the very complex, as you know. This is a picture about a new kind of circuits, the quantum circuit. The quantum circuit is a new processing way to compute about qubits, not bits, but qubits or quantum bits. The qubit is the new information unit. The circuit is the new processing information unit. We have a stack to understand these different layers between the physical layer and the logical layer. As you can see, we have a new kind of processor, the physical quantum processor, with its controls and amplifiers. A very important unity of quantum error correction. The building of the qubits is very, very sensitive. It has a problem or not of decoherence. The steady state of the qubit is not very, very secure. And this phase of the quantum evolution is characterized by the quantum error efforts to correct the states of the different levels of the evolution of the qubits. When you enter the logical layer, we built logical quantum processors to emulate to simulate the new working up qubits without errors. At the top, we have a new kind of algorithms, the quantum algorithms, whose principal names are Shor, Peter Shor, mathematician from MIT, and Grover. Shor is the mathematician Shor, and Feynman were the guys that have the temptation to translate the absurd, the bizarre of the quantum philosophy and the quantum mathematics, representing the new physics of the infinite small. That make the first algorithm, the algorithm of Shor, that launched the idea to create the opportunity to prove difference and advantages between the quantum computation versus the classical computation. We will see names like quantum primacy, quantum advantage, and quantum supremacy. In 2019, Google, through the quantum process, whose name was Sycamore, tried to prove that it was very, very fast than the classical computer to make the factorization of great prime numbers. Some people really believe that that was true, and Google reached this objective. Sometimes have some doubts, because there is a difference between the notion of physical qubits versus logical quantum qubits. Three areas in evolution in quantum computing area, or more than quantum computing, is the quantum communication and the quantum sensing. Maybe much of us don't have the real understanding that we are now entering the second revolution, the second quantum revolution. The first quantum revolution was when really the transistor was born. The society is taken by storm, 10 to 11 years, months ago, when artificial intelligence done the sensation that artificial intelligence was really begin in 2022, but of course it is not true. What some people now is thinking is that and I totally agree, if you are surprised what artificial intelligence can make now and for the future, quantum computing enlarge, expand all the goods and the bads, and artificial intelligence is able to do in the future. If you think AI is hot, wait until it meets quantum computing. Is an article from Forbes. So people and in Europe, the European Quantum Industry Consortium, starts the beginning of a new era of the industry based in the quantum technologies, understanding quantum technologies, quantum communication, quantum computing, and quantum sensing. There is a new area very important, that is the quantum metrology, that will make will have a great impact in the future also. Where we are in terms of the perspectives about the future, when you look at the hype cycle from Gartner, quantum technology, as you can see, is ascending at the start of the curve in the phase of the innovation trigger. Machine learning is in peak of inflated infections, and virtual reality, IoT and 5G is being entered the plateau of productivity. We have to link. We can't treat the quantum technology isolated from the rest of the technology. Okay, this is a group of the technologies that advance as a group and influence each other now and in the future. Quantum technology, the second revolution of quantum, will accelerate very much due to machine learning and artificial intelligence. And the other is also true. Machine learning and AI will benefit from the gradual introduction of quantum technologies. The first things first, the militaries are the first great group to make use of the new technologies. And there is a lot of impact in military terms, not also in the battlefield and fighting simulations, but mainly in the associated technologies that make up the absurd, bizarre, phantasmagoric way to do things about war and about military. 3 areas in the next future, with a great impact: energy and the quantum batteries, the quantum chemistry, quantum technology in decentralized finance. This is absolutely disruptive. Chainlink, that is one of the players of blockchain in DLT areas, is launching through its Chainlink Labs applications of quantum technology in decentralized finance. We understand that because we really have a great problem to solve in the future about the need to establish from the beginning, from the design, quantum safe and quantum security applications through the post-quantum cryptography and the technology of distribution keys. There is some experience from telecommunication operators, because we are on the verge of a situation of strong impact and in the infrastructure of telecommunications and all the infrastructure related with blockchain and DLT. The quantum networks and telecommunications, mainly about from US government investment allocated 24 million for the development, for research on quantum networks. I would say that this is for research, but the numbers for the operations, for the implementation of quantum networks is much, much larger than 24 billion. Europe has, through the flagship program, 2 billion allocated for research in quantum area. Think quantum is powerful? You're right. Well, but the wait-and-see attitude could cause organizations to miss critical opportunities. This is a challenge for the different kind of entities, such companies or governments. They do have no need to lose the opportunity to test and experiment things before the harmful impacts of technology so disruptive, so different of thinking about for now and for the future. Not also about the competition, but the need that society have to establish the ground of a new way of communication and cooperation today and in the future. So all people is challenged to make some study, to make some research, do your own research about the understanding of the impact of the technologies, try to develop a strategy, monitor technologies, and improve the crypto agility. What is quantum computer? We have mainly a change in the substructure of operations, and mainly the difference between thinking about deterministic versus probabilistic. This is the great difference. This is the great challenge, and all have need to change about way of sensing, thinking, and also talking, saying, and writing. That phase, that transition phase, 5 to 10 years between a world with a linear thinking, deterministic thinking that comes subliminal from the artifacts we use in day-to-day, will be challenged by the new artifacts that sense and think in a probabilistic way. In any way, artificial intelligence is the start, is the on fire to this new world of probabilistic and of block spheres and so. There is already a lot of startups to researching or working in these areas in different levels, applications, software, offer of software, quantum processing unities, and also hardware. So from this slide, you see that there is already one company in the exchange of Wall Street, that is IonQ. The global quantum investment is growing from 2018 to with 248 million, 2022, 2 billion, 226. The technologies that are being used are new technologies, very difficult to describe in in research terms, and even more difficult to implement in the physical world. Some kind remember a metaphysical world in reality. We are talking about technologies about under 10 innovators minus 15 inside the nucleus of the atom. Implementation of supercomputing circuits is being tested by Google, IBM, Intel, Rigetti, etc. And there is also new technology being implemented to work at the room temperature. It is very important to make a jump, a quantum leap, and are being tested a lot of technologies since cold atoms, the photonics, the silicon, and carbon nanotubes. The quantum software, of course, is also an extremely important piece to make this sector, the growing of the sector, and these are some startups and companies to implement different parts of the industry, since quantum simulation, quantum optimization, quantum machine learning, and in quantum cryptography. In all of these sectors, the role of IBM, Qiskit, and Python is extremely important to make simulations, optimization, machine learning, and encryption. Open source software development incumbents taking the opportunity. Qiskit is, as I said, a platform where IBM is giving access to any person remotely. So any one of us could test a quantum computing from their notebook, from their smartphone. This is a synoptic of the relation with the Qiskit platform. Of course, we don't need to be a developer, maybe a normal user trying to develop its curiosity. And here in this picture, you see a lot of and the new numbers about the participation of different countries in the quantum effort worldwide. The future of quantum is impacting improved search through exponential data sets, the streamlined analysis, the optimization, maybe in searching for the best solution of complex and very, very complex problems, and mainly the great tests being used now are in the area of financial forecasting and risk management. According to Gartner's, as the hype cycle, we are 5 to 10 years away. And the IBM's team, 1 million quantum computers connected in global networks. We don't know if these numbers are real. We know that the president of IBM in 1945 said that the world has capacity for only 5 computers. If there is in 5 to 10 years, we will attend a ChatGPT momentum, these 1 million could be 5, 10, 20 million. A brief about a quantum, I named quantum Hello World to getting started to use this, the platform, the Qiskit platform in the Python, only to, in a way, very fast to understand what could be a hello world in trying for you to use these kind of new technologies, where Python is, of course, a centralized point. Circuit basics, building the circuit, visualize circuit, simulating circuits using Qiskit IR, state vector backend. All you have to do is to access the Qiskit.org platform and follow with an IDE this simple pathway to learn the new way to communicate with quantum computers, the circuit basics, the implementation, the creation of the and visualization of the circuit. Here we are testing three qubits. It's a very simple circuit constituted by a quantum gate, here a Hadamard gate, two CNOT gates. After the design of the circuit, we can run the simulator, the Qiskit AR. We have access to this, as I said before, choosing a lot of 20 to 26 to 25 different simulators at the IBM Qiskit simulators platform, and we can see and analyze the different the results of in a graphical form of the software implemented. A lot of simple course is being put it in action. This is one from Udemy, quantum computing in Python using Qiskit, and you can see different terms such as the operations with single and multiple qubits, the big O notations, and the communication protocols, Oracle algorithms, and the different and the most important algorithms since Groover and Shor. Finally, a challenge. I would like like to launch some ideas about the opportunity to think about the quantum careers in order to develop the quantum workforce. And I would like to remember that this is a very challenging domain that begins at university, but we need even more technicals in intermediary terms to make and to build the different opportunities of the sector, creating new quantum jobs, and as I said before, the opportunity to train new quantum team building. I hope in the next year, one of yours could stay here to remember that the evolution of the quantum, and also the opportunity to establish a group with Evolution and Slack about this theme, in collaboration and cooperation with the women in tech that we have listening a little bit about the opportunity, because as I know, and I would like to end with that message, if we all recognize that there is some biases, some problems associated with the development, I have the sensation that we have a lot to do in terms of the tests, the test of codes, not also in the classical programming, but also in the quantum programming. Only some reference for you to explore even more this kind of subject. Thank you.